इस वीडियो में हम कुछ प्रॉब्लम्स डिस्कस करेंगे विच आर रिक्वायर्ड फॉर अवर प्रैक्टिस। सबसे पहला क्वेश्चन है, इज अ चार्ज ऑफ 4.5 इंटू 10⁻⁻19 कूलम पॉसिबल? क्या किसी बॉडी पर हम इतना चार्ज दे सकते हैं? कैन this amount of charge be existed on the body? So this type of question we have already discussed in the previous lecture, and the concept was about the quantization of charge, which is one of the basic property of electric charge. So what exactly is quantization of charge is defined by the expression Q is equal to positive negative n electron, where Q represents charge on body, n here refers to an integer, it should be an integer probably, and E here refers to charge on one electron, and we know that this is the fundamental charge and the value is 1.6 into 10 raised to the power minus 19 coulomb. So in this particular question here we have given the basic thing. The charge on an electron or a body is referred to as 4.5 into 10 raised to the power minus 19 coulomb. Charge on an electron is defined by 1.6 into 10 raised to the power minus 19 coulomb. This is the fundamental charge, fundamental or the basic charge. We know the relation Q is equal to positive negative and E. Here 4.5 into 10 raised to the power minus 19 coulomb is equal to positive negative n. Here E 1.6 into 10 raised to the power minus 19 coulomb. We need to find out the values for n. So we need to divide 4.5 into 10 raised to the power minus 19 coulomb with 1.6 into 10 raised to the power minus 19 coulomb. On dividing 10 to the power minus 19 coulomb and 10 to the power minus 19 coulomb, these both will cancelled out. So we get the relation positive negative n is equal to 4.5 upon 1.6, and we can consider this as a 45 upon 16 after removing the decimal. So on dividing this particular expression by 16, we get 2.8. So here n refers to plus minus 2.8, but according to the quantization rule, it should be an integer. It should be an integral multiple of the charge on an electron. But here comes the value which is a decimal value. Therefore, since n is not an integer, it is not an integer, it is not an integral value, so it can't hold the value. So this value of charge, which value of charge? 4.5 into 10 to the power minus 19 coulomb given in the question is strictly not possible. Is not possible. So I hope that you understand this particular question, that the charge of 4.5 into 10 to the power minus 19 coulomb is not possible to exist on a body. Now the second question, a body has a charge of 3.2 into 10 raised to the power minus 7 coulomb. Calculate the less number of electrons as compared to neutral state. So here this is also based upon the concept of quantization of charge, which is one of the basic property of electric charge. Okay, so the charge of an body is referred to as Q is equal to positive negative NE. So here it is stating that the calculate the less number of electrons as compared to the neutral state. We can assume that plus minus to be ignored here, and we just consider Ne, only the positive values for the sake of simplicity. Because if we want to calculate the number of electrons, so number of electrons must be a positive value. Okay, now if we need to solve this particular expression, here we have getting the value of Q plus 3.2 into 10 raised to the power minus 7 coulomb. And we know that the charge of an electron is referred to as this 1.6 into 10 raised to the power minus 19 coulomb. So plus 3.2 into 10 raised to the power minus 7 coulomb is equal to n 1.6 into 10 raised to the power minus 19 coulomb. So we get the value of n by dividing 3.2 into 10 raised to the power minus 7 coulomb divided by 1.6 into 10 raised to the power minus 19 coulomb. Just focus on this particular segment of this particular expression, that coulomb will get cancelled out. Thus, the value for n will represent no unit. It's just a fundamental number. Now, this is just again the mathematics. This comes under the topic of mathematical physics. Understand the beauty of physics here, because mathematics is the language used to understand physics. So here comes the concept of exponent and power. A raised to the power m divided by a raised to power n will gives us a raised to the power m minus n. Similarly, 10 raised to the power minus 7, 10 raised to the power minus 19 will give us 10 raised to the power minus 7 minus 19. So we know that minus will leads to plus symbol. So this plus 19. And on solving this we get 12. So this particular part is 10 raised to the power 12. So on continuation of this particular expression, n is equal to 3.2 divided by 1.6 into 10 raised to the power 12. So if I would divide this, I get the value 2. Therefore, n is equal to 2 into 10 raised to the power 12. So these are the number of electrons required as compared to the neutral state. So I hope this is clear. This is the particular expression for this particular question. Now moving towards the third question. So let us move towards the third question. A glass rod is rubbed with a silk cloth. This particular question is based upon the concept of friction, because in the concept of methods of charging, which I have discussed in the previous lecture, we have assumed the case of glass rod and silk cloth, that glass rod acquires a positive charge of the value given here, something like that in this particular question, and silk cloth acquired the negative charge. And this was in relation of when the glass rod loses some amount of electrons and it is acquired or gained by the silk cloth. So in this particular question, we need to find the number of electrons lost by the glass rod or the negative charge acquired by the silk cloth, and is there transfer of mass from the glass to silk. So we need to understand this particular question. So the concept here lies of method of charging or the transfer of charge. And which specific method? We have three different methods: conduction, induction, and friction. So this is by friction. Okay. Now moving towards the first question. Here it is given that we need to find the number of electrons lost by the glass rod. Okay. So number of electrons. So we know that Q is equal to Ne. Okay. Number of electrons will be represented as the Q upon E, and the value of Q, the charge on the glass rod, is given plus 19.2 into 10 raised to the power minus 19 coulomb. Okay. Now we know that the fundamental charge on one electron 1.6 into 10 raised to the power minus 19 coulomb. On dividing this, we get the value equal to 12. So this is the number of electrons lost by the glass rod. So we can write here, therefore number of electrons lost by glass rod. तो 12 number of electrons इसने glass rod ने lose किए. Second thing is find the negative charge acquired by the silk cloth. जितना चार्ज उसने लूज किया उतना ही चार्ज उसने एक्वायर किया है. सो दिस वैल्यू represents acquires a charge of 19.2 into 10 to the power minus 19 coulomb. Therefore this is the negative charge acquired by the silk. Okay, so second part is charge on silk cloth is equal to negative value of what the charge is being acquired by the glass rod, lose by the glass rod, sorry. Third question is there transfer of mass from glass to silk? In the previous video, we have discussed about that there is a transfer of mass. But note that the mass transferred is negligibly small because the mass of electron is extremely small. So we know that the mass of electron is 9.1 into 10 raised to the power minus 31 kilogram. By making an approximation, I can consider 9 into 10 to the power minus 13 kilogram. This would I will consider as a mass of an electron. So if I would consider the mass transferred, so what were the number of electrons lost by the glass rod? This was 12. So 12 multiplied by 9 into 10 raised to the power minus 31. So this value is 1.08 into 10 to the power minus 29 kilogram. So this value is very, very small, negligibly small. So we need to understand the notation here that the mass transferred is negligibly small. And the reason behind this particular statement is that mass of electron is extremely small. Mass of electron is extremely small. So this question was based upon the concept quantization of charge as well as the method of charging, more specifically the bifriction method. Now the fourth question is calculate the number of electrons in 100 gram of water. So we know that a molecule of water is represented by H2O, in which it considers 2 hydrogen atoms and 1 oxygen atoms. Each hydrogen atom has 1 electron and oxygen atom has 8 electrons. Okay, as we know that the atomic number, hydrogen leads to the value 1 and oxygen leads to the value 8. So each hydrogen atom has 1 electron. So hydrogen atom will have 1 electron and oxygen atom will have 8 electron. But we need to ensure you that we have 2 hydrogen atoms here. Therefore, if I would consider 2 hydrogen atoms, therefore 1 multiplied by 2 is 2 electrons. And we have 1 oxygen atom, that is 1 multiplied by 8 is 8 electron. If I would make a summation, I get H2O and on addition I would get 10 electron. This is simply the one molecule of water has this number of electrons. So I would write here 1 molecule of water has 10 electrons. We need to find out the molecular weight of water. So what is the molecular weight of water? So we know that the atomic mass, here is water, atomic weight of water. So atomic mass for the hydrogen this is 2 and for oxygen this is 16. Okay, this value is 2 for 2 hydrogen atoms. More specifically, if I would write here for the hydrogen, it is the atomic mass is 1, but here I have 2 hydrogen atoms, therefore it is 2, and for 1 oxygen atom the atomic mass is 16. So on addition, I get the value 18 gram. Therefore molecular weight of water is 18 gram. Now we need to find the value of number of molecules in 18 gram of water. Number of molecules in 18 gram of water. That value is 6.023 into 10 raised to the power 23. This is what? Avogadro number. Avogadro number. Simple. Now, if I would consider, according to the question, number of molecules in 100 gram of water. This is for the 18 gram of water. We need to find the value for 100 gram of water. So we need to apply here unitary method. So 6.023 10 raised to the power 23 divided by 18 into 100. Okay, and if we want to find the number of electrons, total number of electrons in 100 gram of water, we need to multiply the 10 with respect to this particular expression, because we have 10 number of electrons as specified here, 10 number of electrons. So we have multiplied just 10 with this particular expression, and on solving we will get 3.35 into 10 raised to the power 25. Okay, so this is the total number of electrons in 100 gram of water. This is a very important question. Okay, now the next question, if a body gives out 10 raised to the power 9 electrons every second, how much time is required to get a total charge of 1 coulomb from it? To understand the beauty of the question, we must mention the given values. For example, it is given here that the number of electrons is 10 to the power 9 electrons, which are given by the body per second, every second. Okay. Now, if I would consider a total charge of 1 coulomb, so total charge I am denoting by symbol capital Q is 1 coulomb. So we need to find out how much time is required to get the total charge of 1 coulomb from it. So we know that the charge given per second. Why we are writing per second? Because according to the question, it is mentioned every second situation. So it is denoted by the quantization rule. Q is equal to NE, that is equal to 10 raised to the power 9 into charge on the fundamental electron is 1.6 10 raised to the power minus 19 coulomb. So the value comes out to be 1.6 into 10 raised to the, I have just arranged this, 10 raised to the power 9, 10 raised to the power minus 19 coulomb. Okay, just making a arrangement, simple arrangement. Now applying the concept of mathematical physics. Again, I am repeating that mathematics is the key to understand physics, because mathematics is a language to understand the beauty of physics. Now, here comes the concept of mathematical physics, that is exponent and power. A raised to the power m multiplied by a raised to the power n will leads to a raised to the power m plus n. Therefore, 10 raised to the power 9, 10 raised to the power minus 19 will leads to 9 plus minus 19, and on solving plus minus will give minus. So on solving we get 10 raised to the power minus 10. So in continuation of this particular expression, we will find that the charge given per second or denoted by the Q is 1.6 into 10 raised to the power minus 10 coulomb. But if I would say this is the big charge and this amount is capital Q. These are the small charges. How much time it required in seconds to get a total charge of this? So if t seconds is the time required, t seconds is the time required, then capital charge Q is equal to the product of small charge multiplied by time t. Therefore, we get the value of t is equal to capital Q divided by small q, and the value of capital Q is to be considered as 1 coulomb, as the total charge of 1 coulomb is given in the question. So 1 coulomb, and the value of small q we have just calculated 1.6 into 10 raised to the power minus 10 coulomb. Coulomb and coulomb will get cancelled out. Again, here applying the mathematical physics section, if I would consider as 1 by 1.6 into 1 upon 10 raised to the power minus 10. So 1 upon a raised to the power minus m will be considered as a raised to the power m. So the value for t is 1 upon 1.6 into 10 raised to the power minus 10 will lead to plus 10 here in the numerator section. So on dividing and solving this particular expression, we will find that the value of t is 6.25 into 10 raised to the power 9 second. And this time is very large. What a large duration of time. See, t is equal to 625. 1, 2, 3, 4, 5, 6, 7. This is the amount of second it will require. If I would approx, this time required is nearly approx to 198 years. What a large duration. See the beauty of physics here. What a large value of time duration it is taking just to get a total charge of 1 coulomb from 10 to the power 9 electrons every second. So in this particular lecture, we have discussed the 5 problems for practice, in which I have included the concept of quantization principle. I have used the concept of friction of charge. In the next lecture, I will be going to discuss about the concept of Coulomb's law of forces, which is the very important concept of this particular electrostatics branch of the physics. So thanks a lot for watching this particular video.